morning, everyone. Welcome to AWS for Health series. My name is Raghavara Sodabatina. I'm a principal solution architect based out of Boston. With me, my colleagues, they will introduce themselves. Dipansu, you wanted to introduce yourself?
Hi, good morning, everyone. My name is Dipanshu Jain. I'm a senior Gen AI strategist with our AWS Innovation Center. Been with Amazon for about 2 years, and have been working across healthcare, life sciences, payers, providers, doing AI strategy for the last several years.
Faisal, you want to go next?
Yeah. Um, Hi everyone, it's Mofijul. I'm an applied scientist and tech lead at Gen AI Innovation Center. I mainly work in the like a multimodal document processing, a multi-agentic planning, etc. On this line, again, different verticals like finance, healthcare, etc. I'm happy to share one of our assets we developed, which is like intelligent document processing with for prior authorization. I'm happy to share with you guys with my team.
Thank you, Faisal. Akil, you want to go next?
Yes. So hi everyone. Good morning. So myself Akhil Noni. I'm a deep learning architect at AWS Generative AI Innovation Center team. So today we are very excited everyone to showcase our prioritization request solution to you all. Thank
Thank
you.
you, Akil. Niharika, you want to go next?
Yeah, hi. Good morning, good afternoon, good night, wherever you are, everyone. And I am Niharika Jain, a deep learning architect from AWS Generative AI Innovation Center, and I have been with AWS from past 3 years, and we have been working across various verticals, as my colleagues mentioned. So, looking forward for today's session. Thanks.
Good morning, everyone. Once again, I just wanted to talk about AWS for Health. AWS for Health, we are going to run bi-weekly sessions focused on ACLS industry-specific solutions using AWS services. Each session will come with a business problem and AWS solution, as well as we'll also showcase the demo so that you can see the solution end to end, how it is working together. So today's session is our first session, building prior authorization healthcare systems with Amazon Bedrock. The main theme of this session is many healthcare payers, they need to build these prior authorization systems. On this session, we are going to talk about how you can leverage AWS Amazon Bedrock to automate this prior authorization system. That way you can start using this solution. Defonso, can you go to the next slide? So this is the agenda for today's. First, we are going to talk about what is the prior authorization problems, and also we are going to talk about the solution overview. After solution overview, we will get into the demo. Once we are done with the demo, we will go a little deep dive into the technical architecture, and also we will talk about the upcoming roadmap about the solution. At the end, we will conclude with call to action and how to get started to leverage the solution. So with this, I will hand over to Dipansu. And I know we talked about where we are from. You can use the chart to mention where you are from.
All right. Thanks so much, Raghav. So let's dive in. In terms of starting off with the problem with the prior authorization current process, let's first look at what the current process really looks like. When you think about it, it's a simple process where it's supposed to be simple, where with a provider identifying a need for a prior authorization based on a patient interaction, they collate the data based on the necessary documentation. It typically includes the patient information, the diagnosis codes, what treatment is being requested, and the justification for why it's clinically necessary. Once that package is developed, it's shared over with the prior auth is sent over to the payer side, where the nurse receives and they organize the patient medical records, ensuring all documentation is present. At the same time, they start looking at the clinical assessment part, which is where they review the medical documentation to understand patient's condition, history, and the clinical needs. They leverage the criteria that is guided by the local coverage documentation or policies, the required necessary guidelines to apply those specific criteria, and then make a final recommendation with a rating for approve, deny, escalate, need more information. And that is when a decision is finally rendered. On paper, the process looks simple, but where exactly are the pain points? Before talking about the pain points specifically, there are a couple of stats I wanted to start off with. There are over 50 million prior authorization requests every year just in medical Advantage alone. Over 5,000 different prior authorization codes across different payers. $35 billion in annual system-wide costs estimated for just administrative costs for prior authorization. In terms of where the process currently breaks down and where the challenges are, first off, like there's a lot of busy work for staff due to the document overload problem. On the provider side, administrative resources gather patient documentation and typically err on the side of providing too much information and not necessarily what may be relevant. So there's a lot of noise versus identifying the signal. Documentation also includes various formats from medical charts, test results, clinical notes, and the format could also be unstructured with some written notes, scanned forms with varying quality. On the payer side, the registered nurses and other administrative folks, they must review all the submitted documentation. They're inundated with a lot of information which may or may not be relevant. They must determine which rules apply based on the complex documentation and hierarchical rules for which criteria is applicable versus which is not. And this process could take several hours to days, typically, as part of that. When you look at the scale that we mentioned, there was an analysis that estimated around 100,000 FTE nurse time that is wasted annually in just this busy work. The second challenge is because of all of this, the clinical decisions are sometimes flawed in terms of the insurance reviewer, whether they're a nurse, clinician, or administrator. They're working with incomplete information and ambiguous policies. The approval rates vary from 62 to 92% by specialty for the same disease, same criteria, but having different outcomes, which highlights the inconsistency. Uh, One of the estimates was around 25% denials are tagged as clinically inappropriate, and about 92% of the providers report delayed patient care and delayed outcomes. And finally, the third one is when there is a denial or if more information is requested, the entire process repeats itself with the provider recompiling, the payer re-reviewing, sometimes a lot of back and forth, and the ambiguous policy may cause same challenges on like what is applicable, which rule is overpowering the other rule, and the time to value can sometimes get exacerbated with from days to weeks, in certain cases with complex ones even months. On top of this, there's the new CMS mandate, which uh, basically requires the 72-hour processing for the urgent prior authorization request, as well as ensuring that there's transparency into the decision that was rendered as part of it. So to summarize, there's large volumes of documentation that must be reviewed quickly. There's resource constraints, and there's complex decision making based on multiple policy documents and criteria. So we asked ourselves, how can our services build a robust solution to help alleviate some of these challenges? The outcome was our AI-powered clinical review assistant. We built an AI-powered clinical review assistant that works alongside nurses to transform this process. It does three things really well. There's an automated criteria extraction from the policy documents. It looks at the LCD and other policy documents to identify the specific clinical criteria that needs validation. The second thing it does is there's intelligent document analysis, where it reads through long documents, and extracts relevant clinical insights and highlights where evidence is found. And the third thing it does is there's evidence-based recommendations where each criterion provides pass, fail, needs more information determinations. It explains its reasoning, cites exact source documents. The nurse reviews these recommendations, validates the reasoning, and applies clinical judgment and makes the final determination, but in far less time than they typically do. In As a real example, in one of the customers we worked this on, they processed over 10,000 prior authorization requests in the first 3 months, achieving over 95% accuracy and reducing average review time by 85%. Um, the key features to think about this are like it's fully deployable solution with integrated document processing. It supports multi-category document packets, customized rule schema, hierarchical rule validation for subdocuments in a document packet, and processes documents with over 500 pages in terms of complexity in the size of documents it currently handles. In terms of the impact, reduces review time significantly, reduces the human errors, and is always guided by human in the loop. So uh, it preserves that clinical judgment and is consistent with the provides an auditable process that maintains high quality standards. So you may ask, how scalable and reliable is the solution? The answer lies in the strong AI foundation offered by the AWS services. Uh, AWS provides the models, tools, infrastructure, and expertise such as the GenAI Innovation Center to help you succeed in building out the solution that is catered to your requirements. The first thing I want to call out is the model flexibility. Bedrock provides access to multiple foundation models, closed source, open source, and Amazon's own Nova models, which are price performant and highly accurate as well. Second thing is security and compliance built in. Bedrock is HIPAA eligible and maintains high trust certification. Your PHI never leaves AWS environment. It's never used to train models, and all transmissions are encrypted. Uh, it's foundational as part of it. The third thing is the healthcare optimized features. So Bedrock guardrails prevent hallucinations, filter inappropriate content, knowledge bases. They enable RAG generation for the medical policies, and the agents orchestrate multi-step workflows with our prior authorization process. And then finally, enterprise scale. When you go from pilot to production, processing the thousands of prior authorization requests, Bedrock scales automatically. You're not managing infrastructure. It is meant to be serverless. So with that, Mofijul will now walk through the technical architecture and how these capabilities come together.
Mufijul, you are muted.
Thank you. So yeah, thank you, Dipanshu. Let me show you how we design the whole workflow and the whole solution. So this whole solution has like a two workflow. One is for the rule extraction. So if we have a policy document, we extract the rules or the criteria listed in the policy document, and this policy document can be any unstructured document, and we can utilize our intelligent document processing approach, which can categorize this policy document. If we have like a different types of policy document, you can categorize that. We can split the documents and extract the relevant rules from that given policy document. And then we can have like a human expert which can review those rules. For example, there are some of the rules can have like some missing informations, or we need to have better structure these rules in a comprehensive way. So after the review, we can get a rule schema, which will list all the rules we need to be validated for a particular prior auth request. So after getting this rule criteria, like a rule generations step, we can get a comprehensive rule schema. That rule schema we can use in our next steps of deep rule validation approach. So in the deep rule validation approach, we first start with the prior authorization request. So when we have like an intake prior authorization request, which can be any unstructured document, which can like concatenation of different types of document like a medical history, claim history, provider notes, and so on. Then we can use our same intelligent document processing approach to categorize those different sub-document. We can extract some relevant informations, like for example, provider notes, what are the medication history, what is the previous claim history. So it doesn't need to be like in a structured way. Any unstructured document we can use that, or even we have like a structured documents, we can also use that. So in any ways, we can process these documents, categorize this document, and extract the relevant information. Then we can kick off our deep rule validation approach, which essentially going through each of the sub document, and for each rule, we can validate and curate. First step is curating those facts from those different sections of that given document. See, after curating those facts, now we have the facts from across all the document packets. Like for example, I need to check the medical history, or I need to check that whether this person takes some like a particular physical examination, and so on. So we can curate those facts across the whole document, and then we can use those facts to validate the rules. So that validation rules provide a particular recommendations whether we can approve, deny, or need like a more informations, and corresponding reasoning that why we are taking the decisions, like based on what are the facts. So that will help the human expert to review the recommendations, that whether the recommendation can be correct. So we are not only depending on the rule validation. Definitely, we are getting a very good performance with the deep rule validations, but we are kind of assisting the human expert to take a educated decisions based on that recommendations. We can deep dive into that deep rule validations later of that talk. I will pass to Akhil to give like a very quick demo of our whole solution.
Yeah, sure. So let me. Okay. So today I'm going to mainly present how we can do this, use this rule validation process and extract some of the rules from the policy documents, as well as once we extract these policy documents, then we need to use those rules against the prior authorization request. So this involves a two-step process. The step one was we need to extract those rules from those policy documents. So for this demo, we are using this NCCI Medicare coding policy document. This document contains some complex billing rules which are narrated in a text format. And in the step two, once we extract these rules, now we have to validate these rules against a prior authorization document. So this is a document which contains multiple sections here. It contains patient information, the clinical data, and it also contains some operative logs information, and some clinical evidences of the patients and claims details. So these contain multiple sections. All this are scattered across the pages itself. Now let me show you this UI. This is an IDP accelerator UI. If someone who joined this call doesn't aware of this IDP accelerator, let's give me a brief overview of this IDP accelerator. This IDP accelerator is an scalable and serverless solution for automated intelligent document processing and for text extraction, which was built using AWS services. And so this solution can just convert your unstructured documents into structured documents, and generate some valuable data at scale. So in this IDP accelerator, now we are integrated our prior authorization solution as well, where this IDP accelerator is publicly available. So you can easily access this IDP accelerator and deploy this solution, and you can try it out, the prior authorization solution by yourself. So I'm going to show you how we can do this. So yeah, let's start with the two things here. The first thing was we are going to use two IDP accelerator instances here. You can see there are two tabs open. In this first tab, I'm going to show you how we can extract these rules from this policy document. And then once we got the structure rules, and then we are going to use those rules and apply those rules against this prior authorization request document, and just get the recommendations from for each rule. Okay, now let's start with the step one. So for step one, we have to extract these rules from the policy document. So for that, we have to define some configurations for this. So for this demo, we already created a pre-configuration file so that you can easily import that configuration file, and you can easily start with this example here. Yeah, for that, you can just click on this view edit configuration, and you can go into this import button, and you can view this configuration library. Inside this, you can find the rule extraction config file. So you can select this config file. Okay, so we can select this. So let me select this now. And now once we select this, so you can see it is important now. So now, so this is already a pre-configured file for this demo. So it's completely tailored for this demo. But in real cases, if someone want to try it out with their own policy documents, so you can initially or easily just import this config file. You can update this config file based on your use cases, and then just save those changes. That's it. So I will let me show you what are the some of the configurations we did here. So we have added some document type here, and some attributes associated with it. So this we're trying to specify what kind of information we want to extract from it. So I can let me zoom in a little bit more so you can see it. So here you can see, right, we're trying to instruct in the LLM, not in extracting the rules. We also want to get some CPT codes associated with that. We want to also get some description of those rules, and so the page numbers, like citations from where exactly those rules are being extracted. So, and also we also pre-configure the prompts as well for this specific demo, where you can, if you want to see those existing prompts, you can click on this view YAML or the JSON view. You can see all those prompts are already defined for you. So once we have imported this config file, now we just need to import a policy document. So to import a policy document, you can go into this upload document section, and you can click on this choose file, and you can just select this policy document, this policy manual. So once you upload this, then so once we upload this to file, this our system automatically start the process for you, and in the back end it runs the OCR and extract the data, and it will understand the document structure, and it applies some generative AI capabilities and extract the rules from the policy document. So you can see here the process has been started. So for time saving, I already ran this process before. Let me show you what the rules are extracted from this. For this, you can just go into this to this section, like document section, and you can easily scroll to the right, and you can see view edit data, and you can go into this visual data panel, and you can see this in this visual document editor. You can see on the left hand side, you can see this policy document, and in the right hand side you can see all those extracted rule types and the rules. So let me show you some of the rules that are extracted here. When you scroll a little bit more, you can see this rule types. First, suppose this is a rule type, like bundling is one of the rule type. And for this rule type, this C.1 tells that this one of the rule associated with this rule type. So for we can have multiple rule types, and each rule type can have multiple rules associated with it. So that also extracted some CPT codes and some rule text, which is description of these rule types. And we also get the page numbers as well, from where exactly we're getting these rules. In the same way, we got one more rule associated with the same bundling rule type. We got those CPT codes and the rule text as well. When you scroll down, you can see some other rule types as well. So the one more rule type is diagnostic surgical, and the rule number and the CPT codes and the rule text. So in this way, we guided LLM, instructed LLM to extract these rules and get these CPT codes, get this description of each rule type, and also get the citations, so that it will be easy for anyone just while you're reviewing these results, and just get this in the structured format. So once we get these rules, so the next thing was you can easily export or import these rules into the rule validation, and you can easily check this with your domain expertise, and they can easily review these rules, and they can easily just filter out some irrelevant rules and just create some final structured rules for our rule validation. So this is a step one where we can easily extract these rules from the policy document. You just need to just update the config file and just upload a document. That's it. It will generate the rules for you. Now let me switch to the other tab here, and now I'm going to show you the step to like how we can use these extracted rules against prior authorization document. So over here for this demo, I already created a pre-configuration file for this rule validation as well. So you can import from here. You can just click here and then you can just find this rule validation. Just select this rule validation so that it will show you that. Let me show you this. Just click on this import the configuration. It will import this for you. So once you import this configuration, it already have a pre-built configuration for you. It's set up for you. Let me show you some more important things that you're seeing right here. So this IDP accelerator can do so many things. It just not only do the rule validation, as I mentioned, it has some other capabilities as well. It can do classification. It can do the extraction tasks as well for you. So you can easily customize all these features here. You can easily customize you can select your Bedrock models, and you can also customize the parameters. You can also update the prompts as well. So this is easily customizable. The whole the every task that you see in this IDP accelerator. So let me scroll to the bottom. I want to show you this rule validation inference. So once you import that config file, this rule validation inference will be popped up here, and with the toggle enable and disable. And the one more important thing with rule inference was this process involves a two-step process internally. The first step was this rule validation will initially extract these these rules, and then it perform a section level extraction. So let me give you some little bit overviews. As I mentioned earlier, this document contains multiple sections. Right now we want to process each section against all the rules. For example, if you have like 7 rules defined, now each rule need to be validated against all the sections. Now the first step of this rule validation inference was we, it will just independently perform section wise for each rule, and then it will generate a intermediate curated clinical evidence for us. And then once we have these intermediate curated evidence for section level for each rule, and in the step 2 we have this rule validation orchestrator. What this step going to do was this is not only just consolidate this rule, this orchestrator tab, it's work intelligently here. It just look across all the sections for this rule, and along with that it will try to identify and try to get some connecting those evidences together, and then generate final determination response for each rule. I'm going to talk a little bit more about this going forward, but overall, this rule validation has 2 steps. As I mentioned, the step 1, it has rule inference. It just generate intermediate responses for us across each section, and this rule validate orchestrator, it will just give you all those. Just look into all the sections and give you responses in a deterministic way. Okay, now for this specific demo, I'm going to use Sonnet 4.5 model for both this rule validation as well as for orchestration process. And we can easily customize these parameters as well, and we can also customize the prompts as well. But for this demo, I already have predefined this process for you. So when you scroll to the top, you can see 2 more sections here. One is document schema section. Over here, we define some of the classes here. These classes are like sections. So now, for suppose our prioritization document contain multiple sections. So we want to process each section individually. Now, we can define all those sections as a classes here. Again, for each class, we can also define set of attributes. So if you want to extract some specific attributes from each class, from each section, here you can define this patient date of birth, type of service, member ID. You can define these kind of attributes so that LLM can extract these entities, these attributes, and we are going to use these attributes and we're going to give us a context to the LLM for rule validation. And we can also have one more one more thing here, which is rule schema. Over here, this is the most important place where we just define all our rules. So which we already got it from the step one. Here we already defined all those rules. So for this demo, we considering the 7 rule types. Again, for each rule type, you can see set of rules here defined. So for suppose this bundling rule, it has 5 different rules associated with this bundling rule type. And the detailed description for each rule type, you can see you can provide detailed description about this rule, so that we're guiding the LLM to look into these descriptions and then validate these rules against your prioritization document. Okay, so now, and we can also update the prompts as well. So you can just go into this and you can update the prompts accordingly basing on your so you basing on your documents on basing on your use case. Just update this accordingly. So yeah, once we imported this config file, the next thing was we just need to upload document. You can go into this upload document, and you can click on this choose file, and here you can upload a document packet. Here I'm going to upload this. Just upload this one. Just go back to this document list, so you can see a process has been started for you. So for time saving, I already ran this process before, so let me click on this. I want to show you how these rules are extracted. So there are two couple of things here. The first thing was the document section where we define all the classes, right? Initially, this process will identify the sections from the document and also group this together based on the page IDs. For example, you can see the first class is identified as PA administrative, and the page IDs has been given like one or two. It tells that the pages 1 and 2 is this PA administrative class. And you can also view those entities which we define that you want to extract from this class. When you go into this visual document editor, you can see it extracted all the entities for you. Yeah, so in this way, for each class, let me close this. For each class, it will extract all the entities, and we're going to use this, and we're going to send this to the rule validation step, as well as a extra context. Now let me show you this rule validation summary. Once this process is completed, this rule validation summary tab will be appearing for you. So click on that, and you can see it's a detailed report about this rule validation that you can see here. Initially, it will show you the overall statistics, and later on, it will show you how many rules are processed. So from this, we are trying to process around 14 rules. Inside that 14 rules, 7 are passed, 6 are failed, 1 is information not found. When you scroll down, you can also see rule type based summaries as well. So for this rule type global periods, we have 2 different rules defined for this. In this, one is pass and one is fail. And when you little bit scroll down, you can also see detailed information about each rule. For this rule, the recommendation is fail, and the detailed reasoning why exactly the recommendation is fail, and also provide some supporting pages to this. In this way, you can see all this detailed information for each rule type. You can see for some of the rules it says pass, and it also provides some detailed reasoning why this rule is recommended as pass, and the citations for this, from where exactly they able to identify the specific information in the document itself. Okay, so now let me give you some high level overview how it is working in the backend itself. So let me click on this view processing flow button. So over here, you can see this whole workflow. Entire is a very big workflow. So initially, you can see the classification step, and then it's gonna do the extraction step for us. It's gonna extract all those rules from each class. So everything. So if we have multiple classes, all those sections will be processed in asynchronous way, which is in a parallel way. And when you scroll to the right, you can also see the rule validation step here, where you can see the rule validation step. This also processing in a parallel way. So if you defined like multiple sections in the document, for suppose if your document has 7 sections, then all those sections are being processed independently initially, and these sections will initially identify the evidences, curated evidences of the clinical data, and then it will store into the S3 bucket. So once we store this into the S3 bucket for each section, then in the next thing was the orchestration step. Let me scroll to the right. I want to show you the orchestration step here. Yes, this is the orchestration step. So what this step is going to do was it takes all those intermediate responses. Again, it will intelligently look across all the section responses for each rule, and it will generate some determinated responses for each rule. And this kind of two-step process helps us for mainly for scalability, as well as this process also helps us for handling very large and multi-section documents for us. Okay, so now with this architecture, we can get like parallel scalability. We can also get section level precision, and we can also get the cross document intelligence and a detailed reasoning for each rule. So with this, the whole process, with our current benchmark environment, we are almost achieving 18x efficiency um, with the end-to-end latency when we compared with our sequential processing. Yeah. So this is how we can just extract these rules and validate these rules against the entire document. And there's one more important feature which I want to show here was, so once we have these rules extracted, right? So now we can do some quick analytics as well. You can go into this agent companion chat. Over here, you can easily ask some analytical questions about the rule validation processes that you have done. You can just ask question like, can you give me the bar chart showing the past percentage trends for rules over time? So you can see here, it gives a very beautiful bar graph for us for just showing the past percentages for each rule type that we defined. So this happened across the whole historical processes, so that we can also ask some other questions as well, like, can you give me the pie chart showing some past fail information for this rule validation. So it gives you some past percentages, you can see, right? Like it gives like fail as 40.7%. This is giving response, these responses are curated from basing on your past document processing jobs. Now, so in this way, you can ask any kind of questions. You can ask some compliance related questions. If you want to compare two different documents, you can compare those as well. So overall, with this, you can easily do some analytical testings for this rule validation, and then you can easily generate some good reports out of this. Yeah, so this is overall how this rule validation works. And now let me explain you high level architecture, like how exactly this is stick together. Now let me switch to the other tab. Okay, just a sec. Okay, I'm going to close this now. I'm going to share now. Sorry about this, guys. Okay, I'm going to share now once again. I'm going to share this. Okay, so now I'm going to talk more about this parallel clinical rule validation architecture. So here, so we have. Let me show you the high level.
Okay, your screen is not up yet.
Not a bit. Sorry
You
about that.
can reshare.
Okay, let me stop sharing once again. Share screen. Okay, how about now?
Perfect.
Yes. Okay. So sorry for the delay, guys. So for the initial, I want to just give you like high level overview about this prioritization system. So initially, if someone have created a prioritization request, so here the two primary inputs for this system. The first thing was the rule schema, which we initially got those from the policy document. And then the next step, next input was your prioritization request document. And then once we upload these two things, then it will automatically do the OCR for you. And then you can use the Textract. We are using Textract or Bedrock, depends on the document type. And and then it will do some classification on the top of that document, and it will extract all those entities from each class. So once it is extracted, then the next step was the rule validation. It will generate some intermediate curated medical evidence facts for us for each section. And in the rule orchestration flow, it will try to consolidate and then generate one determined final responses for each rule. And those rules will be stored into the S3 bucket, and this will be available for human expert review. Okay. I just want to talk a little bit more deeper here, the parallel clinical rule validation architecture. So right now we have some limitations with large language models, with their mostly with the context limits, right? So we cannot directly send a very large document to the Bedrock and ask it to validate these rules against the entire document. So now what we did here was, if your document size is very large, so initially, what we're doing was we are trying to send the document. We're getting those sections for each document. We're processing section wise. If that specific section is within that context limit, then automatically it will process the document for you. What if that specific section is exceeds that context limit? So in that case, what you're doing was, we are performing a chunking strategy here by preserving the page boundaries, so that if it will create multiple chunks. So we can define what the chunk size could be. Right now we define the chunk size as 20,000. So once they create multiple chunks, that how we are processing the section wise, it also do the same way here. It will process the chunking wise, chunking wise, as each rule will be processed against each chunk separately. And those clinical evidences, initial evidences, will be stored into the S3 bucket. You can see here, for suppose for this chunk one, we have multiple rules. This each rule will be processed against this chunk one, and it will store all these clinical evidences for each rule into the S3 bucket. So in this way, we can easily process our large documents without any struggles. Yeah. So once we have this, the next thing was how we can do this consolidation. So in the consolidation step, as I mentioned, we're going to get this intermediate evidence store where it has those consolidated results. Then our all those rules are being will be processed independently against that evidences that we collected in the step one, and then it will try to create a determinate responses for each rule with some evidences attaching to that. And you can see here, all at the end, all those rules responses will be combined and create a final summary and store that into the S3 bucket, and it will be available for human review expert. Yeah. So this is the overall picture, like how we design this solution and how we are processing these two steps. Like one is rule extraction and the rule validation. So right now we have two different instances, right? But going forward in the future versions, we're trying to combine both this rule extraction and the rule validation into one application itself. So you can easily just send. You can easily use that in one instance itself. So if you want to start with this, you can easily, these are completely available in the IDP Accelerator solution. So you can easily uh, just deploy this solution, and you can easily import those config files. You can start with those and you can play around by yourself. And yeah, that's all I have. Now I'm going to ask Niharika to talk about our current roadmap and how we can start with this.
Hi. Thank you so much, Akhil, for the detailed overview. So now that we have covered the fundamentals of the asset that we have built, let's address the questions on on everybody's mind, right? Like, what's next? So looking ahead, we have an exciting roadmap of enhancements that you can see on the screen that will significantly strengthen our assets capabilities. These aren't just the incremental updates, they represent major leaps forward in functionality and the efficiency of the solution. So, starting with number one would be agentic deep rule validation. So, moving beyond simple rule checks to agent based validation that can reason through complex compliance scenarios. You can think of an autonomous validation agents that can understand and can handle the complex regulatory requirements in healthcare. The second one would be the evaluation pipeline enhancement. So, building out the evaluation pipeline, the continuous accuracy monitoring throughout the process, automatic threshold optimization based on what we learn from the production or the ground truth data, and a unified metrics and some unified metrics across the classification, extraction, and the validation. The third is a rule validation and schema generation in a unified process, as Akhil mentioned. And while we were demoing this solution, we have showcased you separate stacks for the rule extraction and the rule validation. Whereas in the upcoming version, we'll be consolidating different stacks together. These two stacks together in a single process for instead of separate ones. So you can just start with one stack, and both of the capabilities will be inside the one stack. The fourth one is the comprehensive benchmarking data set. So we are looking to create a standardized data set, like for example, thousands of documents across industries with expert validated ground truth. It gives everyone a common baseline to measure performance improvements and compare different approaches objectively. So I think like you might ask like why these are important. So let me explain why these are like why we thought we should implement these. So number one is less manual validation work throughout the intelligent automation. And then the second one is continuous quality feedback instead of just post processing checks. And the third one could be like a simple configuration management where one unified stack for both extraction and validation process that will ease the deployment process. And the fourth one is objective performance measurement with industry benchmarks. So these are the roadmap that we are looking ahead. And if we want to, if you so like following today's session, many of you might be like wondering how to begin your journey, right? So here these are the practical steps and key considerations to help you get started effectively. So number one is you can scan this QR code on the screen, and this will show you the open source code repository for prior auth solution powered by GenAI Accelerator, which Akhil has demonstrated in the demo. And then number two would be, so your data is your competitive mode, right? So while everyone has the access to the same fundamental models, it's up to you, like how you leverage your unique healthcare data that will set you apart and drive the real innovation. The number three is rather than building everything from scratch, you can leverage AWS managed generative AI services. This will remove the undifferentiated heavy lifting, allowing you and your teams to focus on what matters the most, solving healthcare challenges and driving patient outcomes. And the number fourth is one of the critical insight is like there is no one size fit for all models. Model choice is highly use case specific, I would say. So whether you're working on clinical documentation, drug discovery, or patient engagement, the right model makes all the difference. So yeah, you can just consider these points, and please don't hesitate to reach out our AWS account team to help you get started. So before I move on, so let me just give you a quick intro to like what AWS Generative AI Innovation Center is. So we also refer it to as AWS GenAIC. So we are a dedicated team of GenAI builders, consist of applied scientists, machine learning engineers, deep learning architects, strategists who have accelerated GenAI adoption for hundreds of customers over the past 2 years. We help with strategic advisory and hand-on building in a time box management engagement to deliver rapid value. So we have deep expertise in leading edge of GenAI use cases and have also built several assets and accelerators to quickly deploy for most repeatable use case patterns. And one of the example is this one, the prior auth one, which is powered by GenAI IDP accelerator. So if you want to learn more about us, please scan these QR codes on the screen for additional resources that can help you get started. And then, yeah, please don't hesitate to reach out the account team to help you get started on your journey. Thank you. And just a quick reminder before we wrap up today's session, please take a moment to fill out our session survey. Taking just a couple of minutes to share your thoughts is incredibly valuable for us. It's how we understand how we worked well, what could be improved, and how can we make our sessions even more helpful for you. Thank you. Any questions?
There are a bunch of questions in the comment window, and I think if Mofijul, you wanna, yeah, I think there's being highlighted on the slide as well. So, what's the simplest, cheapest model that would still yield decent results?
Yeah, I hate to say in this way, but I think it's like a depends on the use case and like the input tokens. Definitely, like a Nova Cloud models is a one of the like a Cloud Haiku is one of the like a cheapest model is there, and the Sonnet model obviously is a one of the a higher tier model, but it depends on like the what is the context size we are using, what is the input of that, like how many rules are validating. So that's how like we develop this asset that you can play with any of this model and you can see the cost there. We can give the breakdown of the all the cost estimate of like what is the input token, what is the output token. You can even use the caching that it's also trim down your reduce your um, token estimations from there. So that's why like we develop this asset in that way. You can play with the different models and come up with the cheapest model, what is the base model, even not only the cheapest. We need to see that the in terms of the latency, in terms of the cost, in terms of the token consumption, what is the base model for that particular use case. Um, okay, so that's a good question. I think so. The non-deterministic, if you think about in the LLMs, we have like some hyperparameters. Like for example, the temperature, top P, top K. And if you notice in your Akhil's demos, in the configurations, we set it to, by default, it's set it to temperature is 0, and top K is a very low level, like a low number, it's like I think 5, and the top P is close to 0, like 0.1. And so if we use a very low value for the temperature, a top P or top K, these parameters can help us to get the deterministic behaviors of the LLM. Because like when you are using the temperature is a very low values, then we have a very selective numbers of tokens. But if we, on the other hand, if you use very high temperature, then it can become like non-deterministic. So tuning those hyperparameter, we can determine and fix the deterministic or non-deterministic behavior of LLM. Uh, yeah, I think this is a live streaming. So after these sessions, you can get that recording in the YouTube. Dipanshu, do you want to take this on? You are the expert on the prior authorization.
Uh, yeah, I think if you're attending the prior authorization technical view, I'm assuming you would be aware of the prior authorization, but this is more around just for everyone's sake. When there is a specific type of treatment that requires approval for it to be performed, there is a prior authorization process, which basically allows, it's the insurer saying, yes, this is approved, and then the care provider can go on conduct that, whether or not it's covered, whether it's not covered, whether it's partially covered. So certain types of treatments require that. I think there were a couple of other questions around the evaluation metrics that you may want to touch upon, Mopajul, and how you're looking at evaluation totally.
Yeah, but right now the like a question is showing in the screen is like a to sensitive patient data. Let me answer that question first, and then maybe we can go to the evaluation metric. In terms of the sensitive data, like all the we are not using like any of these patients data or like a sensitive data. We are not retaining data. All the data is in your environment, will kept only in that environment. It will not be used for any models. It's like we are following the same AWS security principle, and also the guidelines of like Bedrocks. So we are not retaining any of this data. So it is all stay in your environment, in your account. It will not be used by any model or any training purposes. So what is the next question on the evaluation?
But you want to just address the ones that are being surfaced here. Is this
Oh,
a
yeah.
is this in GA
So
service? Yeah.
yeah, this asset is available in the GitHub repository. Like it's like open source asset, so you can download it and install it. The prior authorization module, like GenADP, is already released solution, but the prior authorization we plan to release by end of this week. And this is not like a managed service, so you can deploy this in your account, and then you can like manage by yourself, and you can customize as you want. um that's the interesting question. So it's not like a notebook LLM. It's not an apple to apple comparison, but yeah, per se you can say think about like a notebook LLM for prior authorization. So you can play with the prior authorizations. You can like get the reasoning details, like in the like a Akhil show like a very nice report of like a what is the reasoning of that like a particular recommendation we are giving. So similar to the notebook LLM, so you're like a you're getting the comprehensive report of that particular prioritization request.
How do you evaluate the accuracy of the rule extraction?
So that is the like a one thing in our roadmap. We are planning to incorporate that. So we are planning to utilize the there is a couple of way you can validate that. For example, if we have like some ground truth rule extraction data is there, we can use that in our in our accelerator to um, calculate the accuracy of that. There is a couple of other way we are thinking. For example, LLM as a JAWS as an approach, like whether these rules are very comprehensive enough. In the downstream talks, we are also thinking about okay, like we have the rules, the policies there, and we are validating the rules. But where there is like a missing rules is there. So those LLM as a JAWS can help us to identify that whether these rules are extracted properly. And again, we have the human review, human in the loop in the whole process. So whenever we are extracting some rules, human will review first. So it is not like a fully automated. It's like you think about like a human in the loop semi-automated approach. The human will take care of that things and to evaluate that whether these rules is accurate enough. And we are assisting the human expert through this asset. Akhil, do you want to take this one?
Yeah, is the context limit size discovered dynamically, and does it adapt dynamically? Yes.
Yes. So here in our solution, so we already developed a process where we're trying to figure it out. So what's LLM that you're trying to use, and for each LLM there is a context limit, and we're trying to initially identify what's the document size. We're trying to validate how many tokens are available in that specific document, and then basing on that, we are trying to see whether we need to perform chunking strategy or not. So if it exceeds that specific model document limit, context limit, then we are using the chunking strategy. Yeah.
I think this is the last question. In the UI actions demo, can those be invoked using the SDK or CLI?
Yeah, some of them can be invoked. Like we have like IDP CLI version also. But the rule validation part is still not available in the CLI version. Right now, it's like in the UI version, but this UI can be customizable. We have a very separate UI. You can integrate with the UI. So we have like a release the library of the rule
Yeah,
validation.
well, it's up to the time. Let us conclude. Thank you all for attending the session. Here is the survey link. Please help us filling the survey link so that we can improve our upcoming session. Thank you all for attending this session.